So last time we talked about titration, right? And how do you determine pH at different regions within the titration curve? We talk about 4 different regions, and we use the example to go over the steps, right? Before, in this case, you're titrating a weak acid by a strong base. So before the titration start, it's actually a weak acid solution. So you can just set up the ICE equation to look for proton concentration. That's the monoprotic acid calculation problem we have talked before. And at the equivalence point, the weak acid has been fully converted to its conjugate base, which is also a weak base. So the pH can be calculated based on monoprotic base concept. But you do have to take into consideration the dilution factor there, right? And then before the equivalence point, after the titration starts and before the equivalence point was reached, it's kind of like a buffer system. So you are considering both the acidic form and the basic form based on how much titrant has been ended, how much of the initial species has been converted to its conjugate base, how much is still remaining in the solution. By taking the ratio, you can calculate the pH in the system. Now, I think we stopped here, right? After the equivalence point, the pH will be dominated by the strong base you keep adding to the solution. So can you guys type in the chat box your answer for the last question? I think I left this open to you. 11 milliliter is basically 1 milliliter after the equivalence point. So it's like you're adding 1 milliliter of 0.1 sodium hydroxide to the solution. So it will be dominating the pH, but you need to take into consideration the dilution factor here, right? It is the initial concentration multiplied by the remaining, which is, and then the total will be 11 plus 50. This is your concentration of OH minus. How many sig figs do we have here? Thank you, Shihan. Thank you, Belize. Your number is
4 sig figs, right?
Why? So let's talk about this one first. This calculation, how many sig figs will be remaining? So it's actually 0.1000 times 1.00 divided by 61.00. So it's actually 3, right? Because the limiting number is the 1.00. So whatever you get here, we should have 3 sig figs. I think it's something like this, right? Yes, that's right. That's right, Hope. Because we're going to take the logarithm of this number, right? POH is the negative logarithm of OH minus this number. And this number has 3 sig figs. when you're taking logarithm, it means in the mantissa part there should be 3 digits. Yeah. So POH is 785 sub 3, and pH will be 11.215.